Did I tell you that? Okay, factors here. Polynomial P of x has a factor of x minus some constant if and only if the remainder is 0. Yes. If the remainder is 0, so if the remainder is 0, you know that the divisor, you all know what the divisor is, right? The dividend is the thing getting broken down, the divisor is breaking it into parts. What it's saying is if the remainder is 0, the divisor is considered a factor of the dividend. Is that better English? Probably worse English? I don't know. So when you do the remainders here, and when you're checking to see if a number is actually a factor in there, okay, let's talk about 12. Let's talk about 12. The number 12, what are the factors? 1 and 3. Okay, 4 and 3, 1 and 12, and 2 and 6. Okay, so you guys had that wonderful, like, square on your desk in elementary schools, that was the multiplication table. You could go, like, over to the 6 and go down to the 4 and the answer. Do you guys remember those? You need a big one over here, okay. So what you know is 12 has 3 factor sets, right? You guys do this all the time. You did it for factoring, you did it for all this stuff. So we're looking for the factors, the things that multiply together. There's a lot of other numbers that multiply up to 12. And those might be rational numbers, they might have fractions and decimals, right? But we never talk about those because they end up with like weird things. So we're looking at 4 divided into 12 evenly. What we're saying here is that if the remainder is 0, the divisor goes into the dividend evenly. Does that make sense to everybody? Okay. Carson? What? Okay. No. No. It's a few. It's not definite checking. Okay, so if the remainder is 0, the divisor goes into the dividend evenly. So if 12, the dividend, is divided by 4, the divisor, we know that there's no remainder left over. We have a quotient of 3 that has no remainder. Okay? Same thing with binomials. Okie dokie? So it says, what's going to happen, the reason why we do this, is because I'm going to give you this and say factor this. I'm not going to tell you what your divisor is. Okay, I'm not going to, like, we're going to get away from that. I'm not going to tell you what your divisor is. I'm going to tell you to take this and factor it. It's not hard. It's not. I promise you it's not hard. So it says which binomials are factors in the polynomial. Easy peasy. We solve this one. So x is equal to a positive 1, so that means we are subbing in positive 1. So we've got 1 cubed minus 3 times 1 squared minus 1 plus 3. 1 minus 3 minus 1 minus plus 3. What do I get? There's a positive 1, there's a negative 1. There's a negative 3, there's a positive 3. What do I get? Not just a pretty face. You're a genius. You're a genius. So this is a remainder of 0. So what would we say? What would we say? x minus 1 is a factor. So x minus 1 just a quick question. How many factors do you anticipate with something with a degree of 3? How many x-intercepts would we have? Maximum of 3, right? Do you will expect to get 3 factors? Oh, look at that. Connecting the dots. Okay. Is x plus 1 a factor? I don't know. So we're going to check it. Is it?
Yeah, I don't know. I was just going to keep asking. Is it tricking me? Or no?
Are you sure? Are you sure? What? So we know that x plus 1 is a factor. This is a factor. I'm a little traumatized by that statement. Okay. So this one, again, you're gonna solve for that non-permissible value. That's gonna be your trick to this. I like it. Forgot the original thing. That's the wrong sequence. No, a lot of people don't write out all the steps. Is that the end of the world? Okay. Very true. We have to start time. Are you sure? Are you sure? Okay. Couple of things. I agree with you, Canal. It is not a factor. It's not going, let me just finish this. A couple of other things. If you're going to show all your work, I'm going to mark all your work. If you lose an equal sign, that's a half mark deduction. I'm just, yeah, if you're going to do your work, do it right. Is it a factor? Are you going to assume that?
I would say.
Yeah?
He's on the school number.
Would you?
Well, that's, yeah.
Perfect.
I don't know, I just assume.
So here I've got a positive 27, a negative 27, a minus 3, and a plus 3. Yep. What? There was something maybe, no, okay.
If it's X cubed, like, does it have to be 3 factors?
Because you need to get to an X cubed and X times X. If I have 2 binomials multiplied together, it's going to have a degree of 2. I need that third X to get a degree of 3.
But you assume we have 4, then you can see the last one.
But sometimes you're going to get doubles. Like you may have X minus 1 listed twice. You might have it listed 3 times. Does that make sense? Like, so you try all the other ones and they don't work. That means this is multiplied by itself 3 times. Multiply 3. What? That is a drag. I was doing my polynomial project last night. For in the E-block after school, and it was I had to forgot about the balance, and then I was like, oh yeah, I gotta do that. And it's all messed, but I got it. The McDonald's sign was beautiful. Okay. Determine whether x plus 2 is a factor of this. Determine all the factors. Determine all the factors. So, oh, I worked this all out for you. That's kind of neat. I really need to be less generous. So, first of all, I got to check. So I solved this for the MPV, substituted in, it actually works. So it is a factor. Once I know it's a factor, then I can do synthetic division. Now here's the deal. When you do synthetic division, you need to get a remainder of 0. You told me the remainder of 0 out there using the remainder theorem. If you do your synthetic division and get 3 here, you've done something wrong either up there in the remainder theorem or down here in your synthetic division. And it's all this. Okay. So we did the synthetic division, and I get this. You guys have seen this before. This was on just recently on quiz number 2 for identities. And we had to use our quadratic formula to solve that. I'm not asking you to solve it, I'm asking you to factor. How many times have I taken a mark off because I said factor something and you solved it? A few times in here. Just gonna say a few times. So just make sure if this doesn't factor, if you can't figure out the factors, use your quadratic formula. If you get decimals, don't factor it. Just leave it the way it is. Does that make sense? Now, you might get a factor of the third, and then yeah, check to see if the factor is nicely in your quadratic formula if you're unsure. So these would be my 2 factors, this one and this one. This is going to give me some x-intercepts, but they're going to be a little bit tough. They're not going to be as pretty. That's the only thing I put on page 2. Like such a waste of time. Oh, but then it makes us feel like we're getting through the lesson a lot faster. Right? It ain't that long. Got it? You guys got what that says? If x equals a is an integral of 0 of a polynomial p of s with integral coefficients, then it's a factor of the constant term p of x. Obviously not. Okay, so this is what Thompson didn't teach you. That you all sat in my class and said Thompson didn't teach you this in calculus. All this says, if I say factor this completely and I give you no divisor, you're saying I gotta get some checks to the end of the world. And I'm saying you gotta narrow that down a little bit. What it's saying is you take the factors of 6. You take the factors of 6, and those are the ones you start to try. So 1 and 6, 2 and 3, hold the fort, there's a few more. -1, -6, -2, -3. So yes, you have to guess and check, Carson, but you're not going to pick 10. You're not going to pick 22. You're not going to pick 6 times. You're picking from the factors of your constant term. Okay, that's where that comes from. So yes, you're going to have to guess and check, but you're going to narrow it down to those factors. I would always recommend start with 1. Sometimes it works, sometimes it doesn't. All right. So I'm starting with +1. So f of +1. If I put 1 in there, that's going to be 1 minus 2 minus 5. So that's 7. That's 6. Does it work? Yes. +1. -7. +6. Okay, that works. So if I know that, because I did the math, so I didn't show any of my work. I did it all in my docket, or maybe on a separate piece of paper. What do I know my factor is if I've substituted in +1? X minus 1. So x minus 1 is a factor. Because if you solve this, it gives you a positive one. So you kind of have to unsolve it. So now what do I do with that? Now that I know that, you know what a factor is. What do I do next? Don't spend your time checking after this, because then you're guessing. You're going to use synthetic division now. So now negative 1 goes on the outside. I draw my little box. I've got 1 minus 2, negative 5, positive 6. All of the degrees are represented. So I have x squared minus x minus 6. Am I done yet? No. Next step is I'm going to have to try to factor this. Can I factor that? What are they? What kind of 3s? What kind of 2s? Yeah. So the answer to this question is 3 factors. X minus 1, which we found with our remainder theorem. And then the other ones that we did the synthetic division and then we just factored based on our grade 10 knowledge. This is your answer. You need all 3. You can't leave them scattered across the page. I'm going to get upset. And the worst thing you can do to a teacher is make us give up. Like, if the teacher's giving up on you and the math that you put on the page, and I'm not looking for places to give you marks. I'm always trying to find where you're pulling it from, but if it's impossible, eventually I just look at it and say, moving on. So don't make me do that. All right. So what numbers am I going to try? Yeah. So we've got negative 1, negative 3, positive 1, positive 3. It's beautiful when it's a prime number. Then you can figure this stuff out. What are we going to substitute in there? We're going to try 1 or negative 1? 1. Okay. That's not good. Negative 9, positive 5, so I got a negative 4. So that doesn't work. That does not work. Thanks, Canal. Glad you're here. What's coming next? What do you want to try? Negative 1. Does that one work?
Yes.
Yeah. So we know that x plus 1 is a factor. I mean, I guess if you like to keep going with all the factors, if you get a number like 36, then all of a sudden we've got a lot of factors to check, and I would just hop right into synthetic division. So plus 1 goes on the outside, create my box, and all my degrees are represented. So 2, negative 5, negative 4, positive 3. So I'm left with 2x squared minus 7x plus 3. I'm not writing those down anymore, but it does help if you go remainder, work backwards, constant x squared. I always found that helped me when I wrote it out like that. I'm getting past that now. Can I factor that? Yes, you can. What are the factors? I got a 2 in front. Okay, you still can factor it because you're looking at 2 times 3. Remember, this is complex trinomial factoring from grade 10. So I got the factors of 6 that add up to negative 7, negative 1, negative 6, right? So this would be 2x squared minus 6x minus 1x plus 3. So I'm going to take out a 2x here I'm going to be left with x minus 3. I'm going to go to -1. I'm going to be left with x minus 3. So my factors are, I'll just go over here and write them. X plus 1, 2x minus 1, and x minus 3. I might do this on a separate piece of paper. This may be on my rough notes. Like if you're looking on what you do on scrap paper, anything on the page is going to be, I have to look into for marks. Okay, Canal, you guys are in charge. I'm taking a break. I feel like factoring it out. 8 has less factors than -24. And I will tell you that 1 isn't one of them. I try it too. Okay. Try it too. Either one. Oh, geez. Where am I subbing it into? Am I subbing it into the original? No. I'm subbing it into the other one. Oh, I definitely almost screwed that up. Did you? Okay, so we found 2 factors so far. We found this is a factor and this is a factor. Okay, so now we're going to do synthetic division again, but now we're using the degree of 3. We're calling it with the degree of 3. So -2, 4, 8. Let's go ahead and screw this one up. Ouch. Can you factor that? Hopefully, difference of squares. So that factors to x plus 2, oops, x minus 2. So now I got to list them all in person. I've run out of room. Okay, so we have x minus 3, x plus 2, x minus 2, and x minus 2 multiplicity of 2. So for those of us who are not, have no clue what multiplicity is, I promise it's coming up. So we have x minus 2, and how many do we have? 2 of those. Be efficient and do that. If I had 3 of them, it would be to the exponent 3. If I had 4 of them, I got 1x plus 2, and I have 1x minus 3. These would be all my factors. Would you be wrong if you wrote out x minus 2 times x minus 2, x plus 2, x minus 3? Would you be wrong? Would I drop any marks? Right? Jerome, this is why it'd be helpful if you pay attention. So there's my first one. There's my second one. There's my third one, and there's my fourth one. All right. So word problem, nothing terrible. A form that's used to make a large rectangular block of ice comes from different dimensions, such that the volume is volumed by that. Determine the possible dimensions. So the difference between 3.2 is it gave you the divisor. 3.3, you're just trying it out. So which ones am I looking at? What am I trying to find? What factors am I going to track? Factors of the 12, right? I'll tell you, the ones don't work. Close, but no. Yep. -2 works. 2 doesn't, but -2 does. So if I put in b of -2, I've got -2 cubed plus 7 times -2 squared plus 16 times -2 plus 12. So I've got -8 plus 27. Minus 36 plus 12. So those give me, my positives gives me 39. I missed something? This should be 38. 28, and this should be 32. Where are you guys? You guys are not helping me in my multiplying. Okay, let's try this again. So my negatives add up to -40, my positives add up to +40. So my answer is 0. So that means x plus 2 is a factor. So 3.2, I give you the divisor. 3.3, you're required to use the remainder theorem to find the appropriate factor. What do I do now? Synthetic division. How many factors do you anticipate? How many factors do you anticipate? 3, right? Because it's got a degree of 3. So I know what 1 is, and then I have this binomial here, or triangle here. So I've got x plus 2 for my first one, and then when I factor this, it's going to be x plus 2, x plus 3. So those are the possible dimensions. So whatever they are, it would be x plus 2 centimeters, x plus 2 centimeters, and x plus 3 centimeters. Yeah, you're going to do it when it's dimensions, you got to put units on it. Missing a unit will take away a mark. And that will suck on a 1 mark question or a 2 mark. That's it, ladies and gentlemen.